On number 5, we have a system of inequalities, which just means we have more than one that we're going to graph on the same coordinate plane. Now, both of these are in slope-intercept form, just like the number 4 was, but on your test, you have one that's not in slope-intercept form yet. So all I did is took the second equation and wrote it similar to one that's on your test. And so if you had this inequality given to you, you still would need to get y by itself, which means you need to get rid of the 2. So you're undoing multiplication, so you would use division. So you would divide by 2, which means you would have to divide this whole side by 2 as well, which means both terms would be divided by 2. So then you would have the y by itself. Your slope is the number in front of x. Well, in front of x, there's not a number, there's a sign. It's a -1, but it's being divided by 2. So that's the fraction -1/2. And then this 8 divided by 2 is the 4. So this inequality would give us this one in slope-intercept form. So now they're in both in slope-intercept form. We can graph them. Remember, this number, the constant, the number without the x, is our y-intercept. So for the first inequality, I'm going to go to -3 on the y-axis, which remember is the vertical axis, down to -3 and place a point. Then I'm going to use my slope, the number in front of x, which is 2, to use my slope to graph other points. Remember, slope is a fraction, rise over run. So when you only have a number that's not a fraction, you make it a fraction by putting it over 1. So 2 is the same thing as 2 over 1. So that means I'm going to rise 2 and run 1. So when I rise 2 and run 1, I can place another point, and I can keep doing that over and over again to get other points on the graph. Remember, you can go the opposite direction as well. Instead of going up 2, you can go down 2. Instead of right 1, you would go left 1, and you can come up with the other points on the graph the other direction. So all of those are on the same line. Remember, then you have to decide whether to draw a solid line or a dotted line. Since this inequality has the equal to bar, this line is part of my solution, so I'm going to do a solid line to connect the points this time. When there's not an equal to bar, like in our second one, we use a dotted or a dashed line instead. Now I need to figure out again which side of the line we need to shade. So remember, we use our test point 0, 0. We're going to replace the y with 0, and then our symbol is greater than or equal to. The x was 0, 2 times 0 is 0, and then -3. So 0 minus 3 is a -3, so we want to know, is 0 greater than or equal to -3? Yes, 0 is bigger than -3, so I want to shade the side of the line that has the point 0, 0. So I'm going to shade this side of the line on this one, since that's where 0, 0 is, and that makes a true statement. Now I'm ready to graph the other line. So I go to the y-intercept, which is 4. So on the y-axis, I go up to 4 and place a point. And then I'm going to use my slope, which is -1/2. Remember, with a negative slope, my line should be going the opposite direction. Uphill slope is for positive slopes, and downhill slopes are for negative. So that -1/2 means I can either put the negative with the numerator and think of that as -1 divided by 2, or I can put the negative with the denominator and think of it as 1 divided by -2. I just can't make both of them negative, because if both the numerator and the denominator were negative, then my slope is actually positive. So if I do -1 over 2, that means I'm going down 1 and right 2. So from my y-intercept of 4, down 1, right 2, down 1, right 2. I could continue doing that and get points this side. I can also do the other way, which is up 1 and left 2. So go up 1, left 2, up 1, left 2, up 1, left 2, and get the points on the other side. Now on this one, I'm not going to do a solid line because I don't have the equal to bar. I'm going to do a dotted or a dashed line through those points, and then I need to figure out which side to shade again. So using our test point of 0, 0, if y is 0, I'd have 0 is less than -1/2 times 0, anything times 0 is 0, plus 4. So 0 plus 4 is 4. So is 0 less than 4? Yes, 0 is less than 4, so I'm going to shade the side of the line that has the point 0, 0 on it. So in this case, it's this side of the line. Now my solution is where both of those intersect. So this is the solution to the system, is this double shaded area.